Okay, having a look at the 2021 Tech Active paper question 19 for maths methods. So we've got a random variable x defined over an interval a to b is uniformly distributed. Now this is the key thing about this question. When I read it initially, I just read it as normally distributed and then realized partway through that I'd made that, just read that by accident. So uniformly distributed, and its probability density function is defined by this function here, and the expected value and variance of a uniform random variable are, and it's given the expected value and the variance there. So from the start, then we've got a manufacturer has observed that the time that elapses between placing an order with the supplier and the delivery is uniformly, and again they're not normally, uniformly distributed between 100 and 180 minutes. So that gives us our A and B values. So we can write our f of x is going to be equal to 1 over 180, take 100 there, so that will be 1 on 80. And then we can also go and work out our expected value, because we can do the 100 plus 180 over 2, which is going to give us 140. And we can work out our variance, because we have our 180 minus 100 squared over 12. So that's 80 squared on 12, which we can work out as 533.33. And then to get our standard deviation, that's the square root of the variance. So we can just do the square root of that answer and we get 23.09. If you look at the QCAA solutions, they do leave that in surd form rather than getting that decimal answer there. It doesn't have any marks deducted if you don't keep it in surd form though. Then we want to determine the probability that the time between placing an order and delivery of the order will be within one standard deviation of the expected time. So our expected time is the 140. So we're looking at 140 plus or minus that 23.09. So if we do 140 plus that answer, we get 163.094. And if we do 140 that answer, we get 116.906. And so we're looking for that probability. Now that's where we can go back to that original equation there, and we know that the probability is going to be the area under the curve. So if we do the integral of that, so we can pop that function into our calculator, we can graph it. It's taking a little bit of time, and just checking what my window is. And we only will need to go to 1 there for our probability. There's our function there. I might even change it to be between 100 and 180, because we know that's the values that we've got there. And then change my window to go down a little bit further for my y, just to see that a little bit better. So there's our graph. We want to go between, so do the integral between the 116.906 and the 163.094 there. It shades in that area for us, and it gives us the 0.57735 as that probability. If you look at those QCAA solutions, you will also see they show a second method of doing that, where you graph. That first one, you still have to work out the expected value, you still have to work out the standard deviation so that you can look at those areas, but you can show that graphically, which is very similar to looking at it on the graph and doing that this way as well. But I've just used the integral function on my calculator to do that. Hopefully that helps.